Hello. This is a quick video on Sail. It's Python library based, written in Rust. I think it's based on Data Fusion, and they're using Delta kernel Rust. I think they build their own parser and optimizer. Not sure, but the compared to other engine like DuckDB, Polars, and friends, they aim for excuse me, API compatibility with Spark, both SQL and PSpark API, and it's good actually. It's quite good. So here I have this notebook, and the interesting part is I can switch between Python and PSpark, and it works just fine. The only difference here, it will detect if there is a variable Spark, then I'm running in PSpark. Otherwise, yeah, if it's not, it means it's Lakesail. Otherwise, it's Spark. I'm just putting vlogs just to refer to Fabric native engine. So you install I'm using like a new build because there is the integration with OneLake is not released yet. So you install two packages. You install the Sail itself, and the second is you install the PSpark client, which is very light client that you can use with Python, Rust, Swift, and like from anywhere, and you can talk to Spark. So for this library, I think it's calling Spark, but in reality, it's talking to Sail. So here, if you are familiar a bit with Spark, is just normal Spark. It's obviously it's not 100% compatible yet, and probably it will never. But the main difference is here. So I'm defining my server. You pass the notice here. You don't need to mount. It works because it's talking directly to OneLake catalog. You just pass the URL, and that's it. And then you say the catalog is OneLake, and then you get a token. Technically, this one is not needed because by default, Python notebook will give you the token. But I notice sometimes it takes some time to give you the token. So if this ran like in 5 seconds and the token you get only like 7 seconds, then you get an error. So just to be safe, you forced here using the notebook credential. So I have the server. I connect to the server using PSpark client. Show schemas, and it's showing me the catalog, which is OneLake here, and the name of all the schemas. Then I generate the data for this test. So simply I count the number of table. If it's more than 8, and then the data exists. Otherwise, just generate data. And surprisingly, like even the data, I'm using tpch gen, which is again written in Rust. So you see where it's going. There is a pattern, like, and Delta Lake to convert from Parquet to Delta using Rust again. Here, as you can see, it's the default Python notebook, so it's only 2 core. The test is using tpch, so it's quite, how to say, it's non-trivial, and it's like 700 line of SQL, and the fact that they work both is kind of achievement, I would say. Here, previously I had Panda, but just for fun, I just changed it to PSpark, although you can work just with pandas. But the trick now with AI, the cost of generating code is becoming virtually free. So here I just copy this and I pass to LLM, like the free one, and just give me back PSpark. Yeah, there is subtle difference. So for example, in Spark, if you want to use a schema to be, if you want to change the schema to be the active one, you write use schema, then the name of the schema. But for Fabric Spark, you just write use schemas. So I had to make this switch. But then after that, show tables, and I got again the schema, which they called here namespace, and the same catalog and the name of the tables. Then I get the back the result, which is the query and the duration, and then I assign the engine here, the time, and the scale factor in this case is 10, so it's 60 million, which is okay considering it's only 2 core. I remember like 2 years ago, I used to test it with like Cloud Data Warehouse, and now I'm just running it in Notebook. So that's progress, I guess. And then you can write to Delta. Like I remember before when I wrote to the same table, I couldn't read it back. There was some compatibility between the two writers, like with Delta. It's better just to be safe, just to use one writer and don't try to mix writers because there is always potential incompatibilities. But here it works just fine. For this particular table, I've written using Spark and Sail, which use Delta kernel behind the scene, I think. I think they added stuff because currently Delta kernel does not support a lot of API, and it works just fine. So for the results, again, this is not scientific. Okay, let's forget the result for now. Then I read back the result. In Spark, you need to change data frame to view in order to run it in SQL. I think they fix it. For me, it sounds strange. Why just not query data frame? I think the latest version 4, I think they fix it. I'm not sure. So here, yeah, this is just Spark. But here, another example where it's not 100% compatible. So in Pivot, it does not support Pivot. So, but still, there are some limitation in write. So you cannot say create table as select. The way is you need to do create table and then you insert. But you need to use the path, not OneLake, because OneLake catalog API for the moment are read only. There is no write support yet. Hopefully coming soon, we'll see. And the result is so for with 2 core, it's around like 3 minutes. Keep in mind it should be faster, like when you define your table and you write directly the location, so there is no calls to OneLake, it will be faster because currently, and this is not like specific to Sail on OneLake. Like if you have an engine that does not cache the table state in the internal catalog, it become a pain because just for consistency, because you need to know, especially if you want to do write, you need always to know what's the latest status of the catalog. Otherwise, but if you are doing read, it makes sense to have cache, but currently there is no cache. So anyway, so here 3 minutes, then I put with 4 core, then it's like 100 something, and here I think it's around 60, so less than a minute. And here I'm using like Respark, so here vlogs. It's more or less the same. And here the open source Spark without acceleration. Obviously, it's not fair comparison, because Spark is distributed, so you have always executor and the driver, which add overhead, but obviously it does scale. So you can go from 1 to whatever, 100 terabyte, it will work just fine. But for small data set like this one, which is the equivalent of 10 gigabyte and compressed. Obviously, when you have just an engine that's pure native code and there is no Java at all, then obviously it has an advantage. So yeah, it's an interesting project, especially the fact that what I like about them, they did not try to write their own engine. It's based on an existing engine. Obviously, they leverage data fusion. They leverage as I said, Delta kernel, Rust. I think but they have their own. If I understood correctly, they have their own parser and optimizer, and probably they need they're going to do some work on make it distributed, if I understood correctly. But anyway, it's very interesting, and yeah, that Rust seems to be everywhere. So, for example, if you take RORS, it's a foundational library that's used in DeltaRS, Data Fusion, and all the engine built on top of Data Fusion. I saw that Daft are moving to RORS, and that's good. It means there is less duplication of work, and hopefully engines can focus on more important aspect. There is no, there are some, for example, if you have Parquet reader, one good Parquet reader is enough. You don't have like dozen of different implementation. So yeah, anyway, I hope you enjoy it, and thanks for watching. Bye.